the next piece we're going to investigate here is 10.7, which is polymorphism, which sounds scary maybe, but it is not. This is one of the great pieces of, it's like a gift, right, from the developers of Java. So Java is, relatively speaking, a new production language as far as code goes, right? So Java, for example, is much newer than C++. Java's only been here for like 24 years. So C++ is much older. Java is young in comparison to something like COBOL. COBOL now is having this tremendous resurgence because of, all of the stress that we're putting on some of these very, very old governmental systems that were built 40 plus years ago and relied on COBOL, a very old but very capable programming language. And here in Java, polymorphism is one of these gifts that Java inherited because it is derived from some of those older languages. So let's really look at what polymorphism means. So here, this is on page, with apologies, this is on page 655. Polymorphism suggests that a superclass reference variable can reference objects of a subclass. That sounds mucky. It is not. You'll remember that a reference variable is a class that we define, right? So graded activity exam, this is our reference variable. The reason it's called a reference variable, recall, is that exam is not going to be an integer, a double, a float, a char, a string. Those are our cardinal data types. Instead, exam is a graded activity. So because graded activity is a class that we define, it is a reference variable. It's something that we have to extend object into, and therefore is a reference. So there you go. That's the down payment for 10.6 all this while. So what this tells us is the exam has a variable type of graded activity. So you can see that here in this following statement as well. Fantastic. So we've been doing this now for 4 chapters and shouldn't be entirely new to you. The new wrinkle here is that polymorphism suggests that a graded activity, which remember is very high up on our hierarchy, can actually reference some of these inherited reference types that inherit from it. So recall that graded activity is kind of at the top of our class hierarchy, right? And final exam extends graded activity. So because final exam extends graded activity, this statement is legal. Graded activity exam1. So what this is doing is it's creating an object called exam1 of type graded activity. And here what we're suggesting is we're using the container of final exam to house this object. So exam1 is really a graded activity object that is wrapped up in a final exam container. Here, exam2 is of type graded activity again, but this time it is a pass-fail activity wrapper that we put this in. And here, finally, graded activity exam3. So exam3 is of type graded activity, but because pass-fail exam extends graded activity, we can make this statement also legal. So what would the alternative to this be? Instead of saying graded activity here, we would have final exam, exam1 equals new final exam. Pass-fail activity, exam2 equals new pass-fail activity. So that's the kind of treatment we've been giving it this whole time. But polymorphism suggests that, hey, look, you can rely on some of that baked in, I'm going to use the word intelligence here, baked in intelligence that is part of the Java virtual machine here during runtime. So these statements are legal. So those things can inherit down the chain, those things being exam 1, 2, and 3, which inherit from final exam, pass-fail activity, and pass-fail exam because they extend graded activity. Here's where that falls a little bit short, though. As we'll see here in this little code sample, this is on 656. Graded activity exam equals new pass-fail exam, blah, blah, blah. So getScore works because getScore is a method in graded activity. getGrade works because getGrade is a method in graded activity. However, getPointsEach does not work because getPointsEach is a method in pass-fail exam, not a method in graded activity. So this is trying to go up the hierarchy, which it cannot do. So this is, part of the issue that you'll run into with polymorphism is, hey, it's great if you're just going to use some of those methods that are in the super class, but you run out of utility when you really need to lean on the subclasses here. So that's the idea of polymorphism, is every square is a rectangle, but not every rectangle is a square. It's that kind of idea that, and again, I'm going to come back here to 10.5 to show this figure again. So this is 10-14, and this is on page 647. But this is what we've been doing here with polymorphism, is class A is our superclass. Class B extends class A, and class C extends B, which therefore extends A. So what does that mean? That means I can say class A object with a new reference to class C, and that'll be okay, so long as I only reference methods that come from my superclass. We are going to see examples of this in the code samples section here in Eagle following these videos. It's a really nice concept. It's a really big favor that the developers of Java are handing to you, because this does not work in our older languages like C++, like COBOL, for example. And a lot of our newer languages actually do have this kind of functionality baked into it. So we'll see this kind of thing in JavaScript. We would see this kind of thing in like Python, for example. But polymorphism suggests, again, and this is page, because I know you love page numbers, 655. A superclass reference variable, so an object of that type that you've created, can reference objects of a subclass. And that just means I can do like we see here on 656. We can have an object of type graded activity that is wrapped in a final exam type, because final exam extends graded activity, pass-fail activity extends graded activity, and pass-fail exam extends graded activity.